All right, hello. We are continuing our look at exponentials in this lesson by looking at the property of exponentials when you have a power raised to another power. So for example here, and again, for whatever reason, the parentheses were dropped. So this first situation here should be x to the m raised furthermore to the n. And how does it simplify? It's x to the m times n. Okay, one way to illustrate this, I should say, is if you have, for example, like 3 to the second to the fourth, right? What does that look like? Well, when you raise something like 3 to the second to the fourth power, that means you're doing 3 to the second times 3 to the second times 3 to the second times 3 to the second, right? But furthermore, we have all these 3 to the seconds, which are all equal to 3 times 3. So this is really 3 times 3, times another 3 times 3, times another 3 times 3, times another 3 times 3. Since it's all multiplication here, we can kind of drop all those parentheses, and we end up with 1, 2, 3, 4, 5, 6, 7, 8 threes, so 3 to the eighth. How can we go from here to here even easier? Well, 2 times 4, right? Multiply the powers there. So, and again, all these exercises here do not have their parentheses. So we need to kind of fit these in here. Okay, so 15 to the 3 to the 9 is going to be 15 to the 3 times 9, or in other words, 15 to the 27th power. Here in exercise 2, it's negative 2 to the 5th to the 8th. So it'll be negative 2 to the 5 times 8, or negative 2 to the 40. Okay, same thing for number 3, 3.4 to the 17 times 4, which is 3.4 to the 68th. Okay, why don't you go ahead and try exercise 4 here with the S. What would that be? All right, it would be s to the 17 times 4, which again, we already saw the 17 times 4 there. We know it's 68, so it's s to the 68th. Okay, now, this next step here, it says that Sarah wrote 3 to the 5th to the 7th is equal to 3 to the 12th. Is that right? No. Sarah is confusing some of her exponent properties. Okay, if she had 3 to the 5th times 3 to the 7th, then that would be 3 to the 12th. But 3 to the 5th to the 7th does not equal 3 to the 12th. 3 to the 5th to the 7th excuse me, is 3 to the 5 times 7, or 3 to the 35. So correct the mistake. That's what we did right there. Okay, write an exponential expression using a base of 3 and exponents of 5, 7, and 12 that will make her answer correct. And so that would be this expression right here. In fact, maybe I can just like lasso this thing here and bring it down. Okay, oops, okay. Let's continue on here. A number y satisfies y to the 24th minus 256 equals 0. What equation does the number x equals y to the 4th satisfy? Okay. So let's see here. This is a strange question, so I'm going to skip it. We won't worry about that one. Okay. So here we can see that we have x times y to the n, and as a result, we can take that n and kind of distribute it to both bases here, right? Two bases, x and y, and we can distribute that n to the x and the y there to make x to the n times y to the n, like so. Okay, which, you know, again, you can kind of see the idea here. So if we have like xy to the 4th, for example, that would be xy times xy times xy times xy. Okay, or in other words, x times y times x times y times x times y times x times y. But again, because of the property of multiplication, you can rearrange the order of these, and so we really have 4 x's and 4 y's. And these 4 x's then can become just x to the 4th, and these 4 y's can then become y to the 4th. And so we really just get x to the 4th, y to the 4th, right? So you can distribute that power there. All right, and the next lesson, or next video, we will examine that property.